Alrighty, hello everyone. Welcome to Lowell Observatory's interactive stargazing with a special edition on the Saturn opposition. My name is Claire. I'm an educator here at Lowell Observatory, and I'm with my colleague Wesley, who I'll let introduce himself.
Hi, I'm Wesley. I'm also a public program educator at Lowell.
Sweet. So today what we're going to be doing, if you're joining us for the first time, is that we're going to show you a bunch of really awesome objects in the night sky. And it's really cool for you guys because it's interactive. So if you have a specific object or a question that you'd like to ask us, just put it in the YouTube live chat, and then we'll take a look at it and answer your questions or go to those objects for you guys, and we can discuss the object that we're looking at. So to start us off, we are looking at Saturn because opposition just started yesterday, August 2nd. Now, what opposition means is it means that the planet Saturn is on the opposite side of Earth from the sun, basically. So Saturn is fully illuminated for us, which means that it's going to be nice and bright in the night sky. Opposition is usually some of the best times to look at a planet. So that's what we're looking at here. So we can see the rings pretty well. And of course, we can see the planet itself. Now, Saturn is a gas giant planet. It's mostly made of hydrogen and helium. But Saturn actually has 82 moons. We can see some of them tonight. So if we up the exposure a little bit on the plane wave, we'll be able to kind of overexpose the planet itself. Then we'll be able to kind of pick up on some of those planets, and I'll try to name them out for you guys. So the brightest one kind of hovering on the top, that is going to be Titan. Titan is a really cool moon. So Titan has some of the only liquid on the surface. It's liquid methane, lakes of liquid methane on the surface, and Titan also has a really thick atmosphere. And then if we start closest to the planet, kind of on those three on a line, that's Tethys. In the middle, it's Dione, and then the last one is Rhea. So we can see some of those moons tonight, which is really, really cool. So starting it off with Saturn, which is a great planet to look at. And of course, if you guys have any requests, start putting them in the chat and we'll take a look at them, but we have plenty of objects if you guys are still thinking. So is there anything you wanted to add, Wesley, about Saturn? Any fun facts that you have?
Not a ton of them. Saturn's rings are really cool. We can see them so clearly because they're mostly made of ice, and ice is really, really, really reflective. And they're there because it's just stuff that Saturn ripped apart with its gravity, which is really cool to think about. It's really extreme stuff.
Yeah, so actually all of the gas giant planets have rings to them. So Jupiter, Saturn, Uranus, and Neptune. But like Wesley said, Saturn's is made of little water ice particles, so they're really reflective. But all the other planets are kind of just like these little bits of dust and rock, so they don't reflect very well. They're usually pretty thin. And so for Jupiter itself, I think we discovered those rings in 1780 with the Voyager 1 mission that NASA sent out. So that's when we first actually discovered
1980, not 1780.
Jupiter. Yeah. So yeah, a long time ago. But that's kind of a cool thing, but Saturn's are best and brightest. Now, one of the cool things I like about Saturn's rings is not only that they're water ice, it's cool to think that there's just like water out there in the solar system. So we think that water's like, obviously it's really precious here on Earth, but it's abundant in our own solar system. We just kind of have to look for it in unique ways. But Saturn's full of it for the rings, which is really cool. And those little particles of ice can range in sizes from like as big as a house to as small as a grain of sand, which is kind of cool to think about, just all of those different things. And also about the rings of Saturn, they're supposed to be relatively young. So one of the other reasons that they're fairly bright is because they're so young, they haven't had a lot of time to kind of accumulate dust on top of that ice, so it looks nice and bright for us. And so we think that the rings of Saturn are only about 100 million years old. So they would have been around or just started being around when the dinosaurs were roaming the Earth. So that's kind of cool to think about. They're so young in the solar system, relatively speaking. But that's kind of cool to think about. But I think we have some requests coming in, so we can start jumping to those. So someone asked if we can look at Jupiter. So we're gonna wait for a little while on that one. It's still pretty low to us and we wanna be able to show you some nice detail on the surface of the planet. So we're gonna wait a little while, but we'll definitely go back to Jupiter because we wanna show you guys a look. But it looks like we have another one for Flying Unicorn Cluster. Just because of the name, it does sound pretty cool. I don't think I've ever seen it, so I'm excited. So we're gonna head over there. And what you see in front of you, we have the plane wave software. So we're using a plane wave telescope with a camera attached to the bottom. And so we're gonna search for the object. We may or may not do it by the name. We might do it by catalog number, such as NGC, which is what you just saw. So we're gonna search for it, and then we might tweak the settings a little bit just so we can get the best view that we can. So let's see. It's called the
Flying Unicorn Cluster's a heck of a name.
I know. I wonder where the flying unicorn is. Sometimes
I'm curious. Yeah.
I kind of see it. So it looks like maybe if it's in the right direction, I guess.
It always feels like a game of like squinting your eyes just at it to try and figure
yeah.
out what they're talking about. Yeah.
Yeah.
I think you got like the wild duck cluster, which.
Yes, we can go to that one next if we don't have one. But let's look at this one a little while longer. But sometimes astronomers are really good at naming things, and then other times are just like, where did you get that? So I don't know. I thought I saw it, but I don't know if I see it anymore.
Yeah.
That's a cool object. I've never seen it. So
yeah, it looks like this is an open cluster. So that generally means that these are a little younger clusters of stars normally. And oftentimes they're not necessarily things that form together, but more often just like things that look like they're close to each other.
Yes. So let's head to the wild duck cluster next. And looks like there's a couple questions. So we can go ahead and answer some of those while we're changing the telescope around. So someone asked if the Seven Sisters are visible. So no, the Seven Sisters is also known as the Pleiades, and those are a winter object. So they won't be up for a little while to come. So maybe in a couple months, they'll start to rise on the horizon, but not tonight. So someone
They're
else
on the other
asked,
side of Orion because Orion's chasing them, and currently Orion's not up because the Scorpion has chased Orion away. So.
Oh yes, yeah, you're right. Good way to think about it. So this is the wild duck cluster. This is like a pretty dense open cluster, so you can kind of see that there's a lot more stars packed into the center. But I don't know, tell us in the chat if you think you see anything whatsoever to do with ducks, because I personally do not. So
the only reason I've heard that it's called the wild duck cluster like doesn't actually have anything to do with ducks. Well, it doesn't look like a duck. It's supposed to be that somewhere in that cluster of stars is a V shape, and wild ducks fly in a V.
Yeah, I still don't see the V shape very well.
I don't get it. No, I have never once gotten it. It does not make any sense to me.
Yeah, but it's a cool open cluster. I mean, it shows lots of stars in a
it looks cool. Certainly.
This is a great object for like binoculars or for a small telescope. Some of the prettiest stars that you can see with a smaller telescope or maybe a wider field of view. So this is a great object if you're looking for things like that to do tonight. And also, lots of the objects we're likely going to look at tonight is going to be around the area of the constellation Sagittarius. And that's because in the constellation of Sagittarius, we're basically looking at the center of their Milky Way. And so there's just going to be so much stuff to look at. Lots of nebulas, lots of star clusters, and all of that type of thing. So we'll make sure to go to some of those really awesome nebulas tonight since we have plenty of time.
Stuff. Yeah, no, it's great.
But it looks like we have another request for can we see Neptune or Venus? So both have set at the moment, so we won't be able to see either of those planets. Let's see. We have another one for Messier 106. So that's a galaxy in Ursa Major. We should be able to get it. There might be a problem with it kind of being close to the building that we're using. Just with the specific telescope, sometimes things that are super far north can be a little hard for us to get just based off of where the telescope is positioned and how tall the building is. But we'll probably be able to get it. So we're gonna try right now. The sooner we get it, the better, apparently. So we're gonna check out that one. So this one should be a galaxy. So we'll take a look at this. Ooh, nice.
Oh, there we go.
That looks pretty good.
Yeah.
So it looks like, yeah, you can see lots of that gassy, dusty detail, especially towards the center. Like you can see some of those shadows kind of cutting across that nice bright galactic center, which is where that fuzzy star looking thing is right in the middle. But this just must be another really nice galaxy to look at. And also it's part of the Messier catalog. So Charles Messier, back in the 1700s, was looking for a comet in the night sky. Never really found one, but instead he found a bunch of other really cool stuff, put it in a catalog, and named it after himself, as one does back in the day. And he kind of became famous for the wrong thing, but it's like the most famous catalog today for astronomy. So like kudos to him.
It's very funny. Yeah, all this really cool stuff that he just like wrote down. He was trying to find comets to name them after French nobility so that they would have to pay him a bunch of money.
Oh yeah.
He just had this get rich quick scheme and it didn't work in the slightest.
Yeah.
Very funny.
Yeah, very funny. Maybe he'd like that we still call it.
Right. Yeah.
He could like time travel to today. Maybe he'd think he's like super famous. But
I don't think he'd be too upset.
I don't know.
We should be able to see, somebody asked in the chat, we should be able to see Pluto at some point tonight. We can take a picture of it eventually. It will not look like anything at all. It will just look like another star, but it's kind of cool to see that. Somebody else asked about brown dwarves. I don't know of any that would be bright enough that we could see them even with a telescope this powerful. They're like very difficult to detect because they're very, very dim.
If we can see one, our telescope operators will put one in the chat, and then we can always go back to that object if we do find out we can see one. But it might take us a little bit of time to find one in the night sky that we might be able to see. So we'll try to come back to that one and answer your question fully. But I think someone else asked, can we see the pillars of creation in M16? Yes, we totally can. Let's head over to the Eagle Nebula. I believe that's the name that it's in. So we're going to head over to that Sagittarius area. This is one of those really nice nebulas, kind of towards the center of our galaxy. And it has a really famous kind of object right in the center of this nebula called the Pillars of Creation, which is one of the most famous Hubble images that have ever been taken. So like if you just search famous Hubble images, Pillars of Creation will probably be in the top 5 at least. I hope I'm right about that, but I'm sure it's one of the ones that you'll recognize at least. So we call these types of nebulas stellar nursery nebulas because what you're looking at is where stars are being born in the night sky. This is just a bunch of hydrogen gas that over time will kind of snowball into baby stars. And when I use the term baby, they're still going to be massively huge, but they're going to be young at least. So that's kind of what.
Yeah, maybe in terms of age, not in terms of size or importance or anything like that. Yeah, no.
Yeah.
They're really, really cool. It's mostly hydrogen you're seeing in there, and so that's a lot of why this thing looks so like reddish pinkish. Is that it's why this thing looks so reddish pinkish is that it's like mostly this hydrogen gas, and that tends to be the color that hydrogen gas glows.
Yes. Also, there's a cool fact about this one. So there is an old astronomer here who tried to come up with a name for this object, and I think he was trying to call it like the Star Queen Nebula or something like that. And it was a very interesting name, and I liked it a lot. But I guess we just kept the Pillars of Creation, which is still a cool name, but not as cool.
Yeah, it's a pretty nice name. Yeah.
So I don't know, but that's just a cool thing. But we have lots of other requests, so we're gonna go to another one. Let's see. Trying to check on both of these, see what's up and what's not. Let's see. So we do have a brown dwarf star that we can see. Just got it in the chat. So we're gonna do, it's called Barnard's star. So the thing about this is we can't tell you which one it is in the star field, but it's gonna be there. We just don't know which one it is, basically. So we'll kind of show it to you. We just won't be able to point out exactly which one, because I don't personally know which one it will be in the star field. But while we're changing the telescope around, we have lots of other questions. So I'm gonna kind of scroll up here. Someone asked, is it true Saturn's rings will disappear in the future? I think yes, probably they will at some point in like the far, far future. Things over time will just tend to kind of deteriorate. So Saturn's rings will be one of those things. And if not, Saturn's rings will collect dust and become a lot less bright over time, most likely. So that is something that might happen. So another question, is it true that lately astronomers discovered new forming moon around Jupiter? I haven't looked at that news specifically, so maybe if you heard it on like a space website that is credible, hopefully, then I believe it, but I haven't done the research myself. But lots of things are forming in the solar system all the time. Even though we're mostly set in place at the moment, there's still things forming everywhere, basically, which is really exciting thing for us to be able to check out. So we have hopefully the Barnard star or the brown dwarf star in here. Again, we just don't know exactly which one it is. So we can't.
Can you scroll out a little bit, Sarah, so I can see the whole field?
Okay, perfect.
So I think maybe, yeah. So it's the I think based on some star charts I looked up, I think it's that big bright one at the top there.
Okay.
Yeah.
Sweet. Well, at the very least, if you looked at all the tiny dots, then you saw saw one.
One of those is Barnard's star.
Yes.
Yeah. It's a dwarf star.
Yes.
A while ago. It's really, really cool looking.
Apparently, it is magnitude 9.6, so it'll definitely be visible for us. So, I don't know, maybe it's one of the brighter ones. Yeah, I believe Wesley. But anyway, we have many more things. So someone asked if we can see the Sombrero Galaxy. That has set for us already. So it's more of a spring object. We are kind of moving our way towards fall. We should be able to get M110 for the person who requested that. So that is a globular cluster. I'm excited to be able to see one of these tonight. Always like to pull these up because they are some of my favorite things to look at. So we'll take a look. So M110 is part of that Messier object. So if it has the abbreviation M plus a number attached to the bottom or at the end, that's going to be part of the Messier catalog. So I bet most of the things we're going to look at are going to be part of that thing.
Probably. It's where a lot of the pretty stuff is. There's some other pretty stuff outside of it. M10 is really nice, though.
This is a nice glob.
Yeah, it's a good globular cluster. Not that you can go wrong with a globular star cluster. They're very, very pretty.
That's true. So
they're really, really old and cool. Sorry.
No, go ahead.
They're really, really cool. We're looking at somewhere on the order of about 500,000 stars in this cluster here. Generally, they are like tens of thousands of light years away from us, which means that they are very far away from us, but they're still inside our own galaxy. And they're these like clusters of really, really old stars that formed a very long time ago and have stayed gravitationally bound to each other and got picked up by our Milky Way galaxy as our Milky Way galaxy was forming. And so we have a bunch of these different objects in our own Milky Way galaxy. It's really, really cool. This one's a lot closer to us, actually. This one's about 14,000 light years, it looks like.
Oh, that's like pretty close.
Pretty close for a glob, yeah. So this light we're seeing is 14,000 years old, which is strangely somehow pretty new for something like this. So around the time that the light from this like cluster of hundreds of thousands of stars left it, humans were just kind of starting to figure out the written word.
Yeah, I don't think we invented agriculture at that point. I think that was like 10,000 years ago. So we were still like hunting for mushrooms and stuff, which we still do today. But, like,
that's true. Hannah does it all the time.
That's true. One of our colleagues. It looks like a satellite might have passed through. So kind of like that streak cutting off the corner. We get that pretty often. So you might see a couple of those popping up in all of the images we're taking. But another thing about these clusters is I really like people who describe these objects in very unique ways. One of my favorites is this looks like a sparkly dandelion, which I really like, or like a frozen firework. Then someone has said this looks like
firework.
Yeah, someone has said this looks like unicorn snot, which sounds cool. So,
I don't know if I'm sold on unicorn snot in particular. I mean, I've only seen the one unicorn constellation, so maybe we see some more.
And spiderweb with dewdrops. I like that one too. That's a pretty good description. So if you have a fun and unique way to describe these, I always like to hear them. So you can put it in the chat. But let's see. There's lots of other stuff. So we're going to go to M8. That is the Lagoon Nebula. So let's head there. The Lagoon Nebula is a really awesome object. It is similar to the Eagle Nebula in that it is another stellar forming region. Lots of hydrogen gas, lots of dust in those areas. And
I love the Lagoon Nebula. It looks so pretty.
Yeah, this one's really awesome. And it's a pretty bright one too. So I'm excited to see this. There's lots and lots of stars to kind of illuminate all of the gas around it. Let's see. Checking out the questions. So when the planets get a little bit higher, we can go back to them. They were just kind of close to the horizon, so it was a little bit hard for us to get the telescope operation correct about how much exposure time we should use and henceforth, just because looking through more air and atmosphere makes things a little bit more difficult. So we can definitely go back to Jupiter and Saturn towards the end of the live stream so we can get another good look at that. But here's the Lagoon Nebula. I don't actually know why it's called the Lagoon Nebula because I don't know. Maybe it looks like a lagoon.
Kind of, sort of. It's...
I don't know. But anyway, it's really cool. My favorite part to look at in this nebula is like kind of in the middle. So if you see the really, really bright part right in the center of the nebula and you kind of go off to the left and it's diagonal, it looks like this bar kind of just like standing up. That's just a bunch of dust that's obscuring the light from behind. So sometimes when we look at images or especially at these objects in our own telescopes with our own eyeballs, these can look really two-dimensional sometimes, which is totally not true about these objects. They're extremely three-dimensional. We could like fly through them in like spacecrafts if we have the capability to do that in the future, but they expand massive amounts of space, basically. Sometimes they're light years and light years across, which is really awesome. So these are big objects, even though they kind of look small to us from here on Earth.
Incomprehensibly big clouds of gas, like truly insanely large.
Yes.
Again, mostly hydrogen. If you look at anything in the universe and you guess that it's mostly hydrogen, chances are you're going to be right. It makes up about 70% of all its stuff, and it's very good at making stars, like it's doing in this cloud right now.
Very, very good. So we just did something called white balancing, which is just telling the telescope and the camera that we're using that the little box, in this little box, we're only looking at black and white colors so that it can get the true color of the nebula for us. So sometimes when we don't do white balance for every single nebula, it may look more red or more blue or more purple than it actually is. So this is kind of showing us a little bit more color. So now we can see a little more of those purples and blues kind of weaving into the nebula instead of just that reddish rosy color.
Sort of adjusts for atmospheric effects and stuff like that.
Yeah. So a helpful tool to use so that we can see all the pretty colors, because that's my favorite thing to look at. So
it looks really pretty. It's very pretty looking, yeah.
Definitely pretty. Okay, but let's move on to another object. Let's go to M13. That is totally up. It's another awesome globular cluster. This one's actually called the Great Hercules cluster. It has such a fantastic name because it's basically the most fantastic globular cluster in the night sky. Some people might say it's M15, but M13 is one of the best.
No, M13. Yeah, no, M13 is the best one. People say M15, they're wrong. It's M13. That's the good one. Yes, look at it.
Sounds good.
Oh, it's so pretty. It's another
pretty.
Globular star cluster that I was talking about a little bit ago. So again, about 500,000 stars you're seeing there. And I said they were really, really old earlier, but I didn't quite qualify what that meant. Our universe, all of reality, is about 13.86-ish billion years old. This cluster of stars is about 13 billion years old. So when these things were born, the universe was very, 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 very young.
Yes.
It looks so cool.
This one is right in the heart of the constellation Hercules, basically. So apparently on very, very clear nights, if you're in an extremely dark place, like basically in the middle of the desert, essentially, with no lights around you, you can technically see this object with your naked eye. It kind of looks like a little fuzzy patch in the night sky, which is really cool. I think I've seen it once, like in the middle of the Utah desert, but I wasn't entirely sure because I thought my eyes were playing tricks on me. So
yeah, no, it's really gorgeous. It's about 23,000 light years away from us. Looks really cool.
A great one.
I love looking at it.
So let's head over to the Double Star 70 Ophiuchi. I saw it for the first time in my scope last week and enjoyed the contrast. Heck yeah, let's check that out. That sounds really cool. I love double stars. While we're moving, before we explain this object and while we're moving the telescope, I'm going to answer a couple questions. So we have a question about what kind of telescope are we using? We are using a 14-inch plane wave telescope. And so it is just using mirrors for us. And then we have a Malincam camera attached to the bottom. So that's how we're actually doing the photography. And the telescope itself is 14 inches. So plane wave is the company. Hopefully that answers your question. So this is a double star. So we have a kind of big one right in the center and then a little bit of a smaller one down on the lower left. So what double stars are is that these are for the most part, usually two stars that orbit each other in the night sky. Sometimes, based on our position on Earth in our solar system, and just looking out into the rest of our galaxy, these may not actually be two stars that orbit each other. They could just look really close to each other. But for the most part, most double stars are actually two stars that orbit each other. They're kind of like best friends in the universe. So they stay together until one of them dies or sucks the other one into itself. So
they're best friends until the end, quite literally. After the end, not so much.
Yeah.
They might eat each other.
That's true. They could, but I don't know. That takes a long time, billions of years to happen, I'm sure. So this is a cool one to look at, though. I do like the contrast in size right next to each other. And there might be a little bit of color here. Sometimes it's hard to see when we're using video mode, that specific color. So one of them might be maybe a little more blue. One of them might be maybe a little bit more red. I can't quite tell, but double stars are really awesome to look at in the night sky. These are fantastic objects. Sweet. So just making sure we're not skipping anything over here. We have lots and lots of requests still. Let's see. We have one for M27, the Dumbbell Nebula.
Dumbbell Nebula is gorgeous. Yeah. That's a great idea.
Head there. The Dumbbell Nebula.
Is this one a Planetary Nebula?
Yes.
God. Okay. That's one of the worst. Again, sometimes astronomers very bad at naming things. Planetary nebulas, which is what this thing is, have nothing to do with planets, and also the word nebula means almost nothing. So the name that we have chosen to go with as a science is planetary nebulas. What they actually are is like the skeletons of dead stars that used to be kind of similar to our own sun. They're like similar in mass to it, and so what that meant for it as it got older and died is that the gravity holding the star together could no longer contain the fusion that it was doing. And so it sort of poofs out these outer layers. And somewhere in there, really, really tiny, is a white dwarf, is a really, really small stellar remnant, like the last burning ember of the star as it's dying. Somewhere in there. And you can really only ever see that with a telescope like this that has like a long exposure camera. Even through powerful telescopes, our tiny, puny human eyes are usually no good for trying to find them out. Oh, there it is.
Sweet, right in the center. Looks pretty good. I believe white dwarf stars are going to be stars that last for like an extremely long time as the universe gets old and cold. They'll be like some of the last things to exist, which sounds crazy because white dwarf stars are just like dead cores that are the size of Earth. And so they're just like these tiny little inert things in the universe that kind of just sit there forever.
Yeah, they just take an incredibly long time to like burn through all of their fuel and stuff, yeah.
Yeah, it's kind of crazy how that works out. So that white dwarf star is giving all of that gas energy to glow for us. So it's ionizing all that gas around it. So that's how we can see these objects in the first place. And I think the reason why we kind of came upon that name Planetary Nebula is astronomers back in the day, like William Herschel and stuff like that in the 1700s were looking through their like little handheld telescopes. They looked up at these objects, and since they're kind of spherical in their shape, they thought it might be a planet, and they didn't realize that, so they called them planets, and then we didn't correct them. Like Wesley said, we just didn't change the name, even though we knew better. So but we think that's how it worked. So just old-timey astronomers thinking they were planets, which is totally fair because they do kind of look very spherical. And if you didn't know what it was, then could be.
They're not working with the kind of technology that we are today also.
Yeah, that's totally true. They didn't have the fancy cameras that we do now. So, but this one's a cool one. So in like a couple billion years, this is what our sun will be. We'll become a planetary nebula, just like this, which is nice. But we have some other objects. Someone asked for the Veil Nebula. We should be able to get that. So we're going to go to a specific part of the Veil Nebula because it extends a pretty big chunk of the night sky. So we're going to go to the part that is called NGC 6992. So NGC is just part of a catalog number. It means New General Catalog in the actual terms of it. And it's basically just a catalog of a bunch of stuff in the night sky that we can see. There's thousands of those objects in this catalog. You can like download the list onto your computer if you really wanted, but it'll take a really long time to do that. So I wouldn't recommend.
It's a whole lot of stuff. It's a whole awful lot of stuff to be trying to look through.
So it's kind of extending diagonally through the little view that we have here. So we're tweaking some of the settings just to get a little bit more of that color and detail out. But what
Would you mind
Nebula is
scrolling out a little bit also?
Yeah, let's do that so we can see a little bit more. So this is a Supernova Remnant, if I recall correctly. So this is from an exploding star that has just flung its gas outward very far. And it kind of looks like spider webs stretching across the night sky to me. Like those not very structured spider webs, the ones that you find in like the corner of your house. Not the fancy ones that you see out in nature with like the perfect web. So this is what it looks like to me, but it has some nice colors. Those blues and purples and reds are kind of weaving in there, which is really nice. So this is an awesome object to look at. I really like it. So yeah, we're still playing around with some of the settings so we can get some color through, and some of that nice structure detail might mean the image is a little bit brighter for us, but we still want to be able to see that nebula as much detail as we can. So yeah, kind of just extends from the bottom all the way to the top. Then there are different parts of this nebula. So there's like the Western Veil Nebula, the Eastern Nebula, and it kind of just makes this big loop that we call the Cygnus loop in the night sky. So it's pretty big.
So this is what those clouds of gas look like eventually over a very, very long period of time as that gas like spreads out through the universe.
Yeah, these are cool. So I'm glad we got to see that one. So we already looked at M27, but we have another one for the Snowball or the Ghost of the Moon Nebula NGC 6781. I'd be down to try the Ghost of the Moon Nebula because I don't think I've ever seen that one before, and I'm totally interested to see what this Planetary Nebula looks like. And it's in the constellation Aquila, which is pretty high up for us, so we should be able to get it. It looks like we might have to have a little bit longer of an exposure time, but that's totally fine because, hey, it's a new object that I've never looked at, so I definitely want to see it.
Always fun to see new stuff, yeah.
Yeah. So we can, in the meantime, while we're kind of playing around to get the image for us, we can answer some of the questions. So someone asked, is there a recommended time for the meteor shower viewing in mountain time zone or a peak viewing? So generally, no matter what time zone you're in, oh my gosh, that's a great Planetary Nebula. Sorry, I just had to say that.
Ooh,
but anyway,
yeah, no. Yeah.
Any time zone that you're in, usually early morning, like 1 to 2 a.m. is the best time. So that way you have the darkest skies available. That's when any meteor shower will peak, basically. So if you're willing to stay up or wake up early, whichever one you decide, that's generally the best time that you'll want to see the meteor shower, which will be the Perseids meteor shower that I think is peaking next week, around the 11th, I believe, or the 13th, something like that. But hopefully that answers your question. So this is the Planetary Nebula NGC 6781, or the Ghost of the Moon Nebula. So this is a fantastic little planetary nebula that I didn't even know existed, but this one's awesome. It has some great color. It's pretty big. So we have that nice ring of red on the outer skirts of it. That's going to be lots of our hydrogen and helium. Then when we work our way towards the center, some of that more blue or turquoisey colors, that is going to be more of our like nitrogen, carbon, stuff like that. So we can look at the colors of these and very briefly kind of reverse engineer our ways to what this star was like when it was actually alive, what it was burning through while it was actually going through fusion and stuff like that. But this is a nicely shaped one and I like it a lot. So I'm glad we got that request.
Yeah, this is a good one. I'm a big fan.
Yeah, I'm gonna like save it on my forever look at this list. So
yeah. No, this is a good one.
Yeah. All right. So it looks like we have an asteroid that we want to look at. So we already looked up the coordinates for this, so it's going to take us just a tiny bit of time to pop in the coordinates. We got it through our chat message. So this is the asteroid Julia, somewhere in Aquarius. So we should be able to see it. Magnitude 9, so it kind of might blend in with the stars for us, but we can still get it. I'm not sure if I can personally point out which one it is, but kind of like that brown dwarf thing, we'll see it in some capacity at least. And so I've never looked at this asteroid before, and I'm excited to see it. So yeah, be good. I'm currently doing research on asteroids. So I like looking at them, even though they just look like little tiny balls in the night sky. If you can see them, most of them are too small to be able to see from here on Earth. But They're cool things. I'm just going to check if there's any more questions that we can answer in the meantime. So we have a question. Who names these nebulas? Do names go through some committee or organization? Well, yes, they do, kind of.
Oh, tell them about the IAU. Yeah, here we go.
So I guess nowadays, yes. Back when older astronomers were first discovering these objects, I don't know if they had a specific committee that they used, if they had some sort of astronomical organization. They like wrote letters to each other and try to like deliberate what it should be called, or whoever discovered it gets to name it type of thing. But if we discover a nebula today, then it has to go through the IAU, which is the International Astronomical Union, which is a big organization of astronomers that meets every year to decide on the naming of objects and also the definitions of different things so that astronomers can have a conversation and kind of know what we're talking about, at least on the same level. So it's kind of like why we have dictionaries for English, so that we all know which word means which, kind of what the IAU does for us in astronomy. So they're important. I mean, we have our feelings on them with Pluto specifically, but that's a whole other story. So
again, sometimes scientists are bad at naming things. Sometimes specifically they are bad at deciding what the definitions of things should be.
Yes, very true. So I know, like, say we were looking at Mars right now and we discovered like a new crater that just like popped up and we wanted to name that crater like after my pet dog Ellie, then I'd have to like send a petition to that IAU and be like, can I name this crater this name? And they'd be like, yes or no. So
I'd sign that petition.
Yeah, thank you. I would too, obviously. So hopefully that answers your question. So it's planetary politics, I suppose, as all things are today. Let's see. So it looks like we got the asteroid in there somewhere. Again, it's the asteroid Julia. I don't know which one it is. I can't really say. I don't have any inclination, but it's in there, I guess. So
telescope operator, you got any opinions?
Yes, maybe the telescope operator knows better.
Any bright ideas?
We're looking in the chat right now.
It's
not on the bottom. Okay, perfect. Well,
yeah.
Nice. Sweet. So that
Hannah's usually good at that kind of stuff because she also does asteroid research.
Yes.
A lot of us do asteroid research, coincidentally.
The thing is that there's just so many asteroids that everyone wants to do research on it.
A lot of them. They're cool. They're really cool. It's leftover rock from the beginning of the solar system.
Exactly. Everyone thinks geology is the most boring science, but I'm like, NASA's spending
rocks
billions of dollars to send rovers to Mars, which are geologists, not astronomers, because they look down and not up. So that's just my opinion. But anyway, that's a cool asteroid that we can see. Let's go to another one. So we did have a request for M31 that is in the trees for us, so we won't be able to get it at the moment. But let's go to looking at, we do have a request for Corona Australis Borealis. So that is a constellation. So constellations are too big for us to be able to get in the planeway, but we can kind of show you with the software which one it is. So it's very south. Let's see if we can kind of find it. It looks like it's, known as Sagittarius' Lost Crown. That's very pretty. There it is. So it looks like it's that one. So we can't see an entire constellation through the telescope, but we can kind of show you where it is in the night sky. So that's what it is. Sweet. So let's move on. Someone has a request for the Box Nebula. So that is a planetary nebula in the constellation of Ophiuchus. So it's kind of smallish and faint, but we should be able to get it. It's NGC 6309. So let's take a look at what that is. I believe I've looked at the Box Nebula before, and it was kind of small and faint, but hey, maybe it'll look like a box in the night sky. That would be aptly named, but maybe it's not a box. So we'll see. We'll check this one out. Oh, there it is. So we're zoomed in a lot, but it's kind of like that turquoisey thing. So if we zoom out a little bit, just so we can get more context with where it is in the night sky. So that's where it is, kind of just that turquoise looking star right there. So after we did change the exposure time a little bit, we can get that turquoise color a little bit better, but It kind of just looks like an oval to me. I don't know why it's called the Box Nebula, but maybe if we looked at this with a longer exposure with a stronger camera, it might have more of a box shape, but it's a cute little planetary nebula out there. So let's see. We have a couple more objects. So we have a request for NGC 7000, or the North American Nebula. So we can definitely try it. It is very diffuse and really big, which means that we'll probably only get a section of it if we can even get anything. So apparently it's about 4 times the size of the moon, so it's pretty big. You forgot a 0 in there, telescope operator, just letting you know, for the NGC 7000, I believe. Oh, never mind, sorry. I didn't realize you clicked it. Anyway, we can put it on and see what we see. So let's give it a try. Might take us a little while to kind of tweak the camera settings a little bit to see if we can see anything, to get any type of nebulosity that we can, but let's just take a look. So I don't believe I've ever looked at the North American Nebula with this telescope. So I'm interested to see what it can do for this. And I know there was a question a little bit earlier about what the capabilities are for this telescope. Someone asked about the Cocoon Nebula. We might be able to go to that. We'll keep it in the list, basically. So we'll check out that soon. We have a question for, is Mars visible currently? It is not. It has set already, as far as I know. So we kind of missed it at the moment. So it looks like we kind of are getting some nebulosity through there, which is like pretty good for such a short exposure time. So it kind of looks like it's towards the bottom and kind of arcing up towards the right side of the image, to me at least, but looks like there's also lots and lots of stars in this area too. So that is something that we have to deal with, is working around all those stars to try to get some of that nebula in. But again, this nebula is supposed to be a really, really big one, also a very pretty one. So we're trying to get as much nebulosity, trying to change the brightness and the contrast and stuff like that to see if we can bring it out a little bit more. But with working with shorter exposure times, I'm not sure how much we can get out of this guy. But hey, we got something at least, which is pretty good. And I know that was a request by another person, so glad we could kind of get that going. So let me scroll down here. We have another request for the Pelican Nebula. So this is another one where it's also really big and faint. Let's at least try it, just because we have time to try it, so why not? So let's try that. And then we have a couple more requests, and then we'll definitely go back to Jupiter like I promised at the end of the stream, and go back to Saturn too. So we can check those out. So there's lots and lots of nebulas up, just because we have the Milky Way that is kind of featuring us. It kind of right in the summer arcs across the sky completely. So it starts in Sagittarius and then goes through the summer triangle and then kind of goes down into Cassiopeia. So we just get lots and lots of stuff from that Milky Way area, which is where the North American Nebula is, as far as I remember. So trying for that Pelican Nebula. This one is, I'm pretty sure, going to be pretty hard for us to try and get. I don't know if we can really get it at the moment. Yeah, we're at about a 25-second exposure, which is pretty long for what we're doing here. So let's go ahead and move on to another object. Let's go to NGC 7331, which is a spiral galaxy in Pegasus. So let's check that out if we haven't already. Oh, 7331 is the Pelican. Sorry, I see. Oh, now we got a little bit more. There we go.
Right. NGC 7331 is a different thing.
Yes. Okay. I did not see that in the chat. There it is, though. So it looks like some of that pink stuff up top and then kind of arcing down towards the bottom. I don't know what's called the Pelican Nebula. It's probably one of those things that may or may not be there in the night sky, but sweet.
I don't know if I can quite see a pelican in there.
Yeah, I'm not sure either. But hey, we got some nebulosity, which is pretty good. Usually we don't see these objects very much, but that's kind of cool. So now I think let's go to 7331, if we haven't gone to that, as far as if I'm correct about that, about that being in the chat. Okay. Oh, this is the Deerlick Galaxy. Oh my gosh. This is such an interesting name for a galaxy. I've no idea what it's called this. So the NGC number is 7331. It is a spiral galaxy in the constellation of Pegasus, which is a pretty big constellation in the night sky. But it's also called the Deerlick Galaxy. And I have no idea why it's called that. I don't know if it's like, I just don't know why it's called that. But oh, there's also a couple other galaxies in this field of view, which is really cool. So we have the nice big one right in the center, and then kind of popping up around it is a bunch of different things in there. So all those fuzzy looking stars are other galaxies that are far, far away from us, which is nice. So there's a bunch of them on the left side of the image, it looks like. Sweet. Pretty good one. It has some nice structure to it. There's a nice bright galactic center, and then we can see some of that dust structure kind of making a nice big spiral around it, which is pretty cool too. I also just like seeing all the other galaxies around it. I think that's really cool to see just how many are out there. We think there's trillions of galaxies in the universe, and we're only seeing a very tiny portion, which is pretty amazing to think about. So that is that object.
About 40 million light years, give or take, away from us. So if there was another planet that was looking back at our Milky Way galaxy from the Deerlick galaxy, they would be seeing us from 40 million years ago.
Also, Wesley, I think we're having some trouble hearing you. It seems pretty faint, at least through my computer, so just letting you know of the issue. But anyway, we'll go to the Trifid Nebula next. This is a request from our very own, very famous telescope operator, Sarah. So, of course, it's going to be a great object if she recommends it. So we're going to go there. It's one of those other nebulas near the constellation of Sagittarius in the night sky. So it's going to be one of those really cool ones to look at. Lots of colors with this one. So once we get it through the telescope, it'll kind of make sense why it's named the Trifid Nebula. So it's because there's technically 3 types of nebulas all conglomerated into one nebula, essentially. So we're going to have a reflection nebula, a emission nebula, and a dark nebula. And I'll point each one of those out once we get it fully into the screen for us. But you can already start to see it in there, that pink with a little bit of blue on top, and then some of that dark spider webby looking thing kind of cutting through that pink. So we call it, again, the Trifid Nebula. So what we're doing here is we're using the telescope controls to do something called jogging the telescope, which means that we're moving the telescope just a tiny, tiny little bit so we can get this object more centered for you guys so that we can see it a little bit better. So it might take us just a couple more seconds to get that going. So you can see those jogging controls at the very top of the screen for you guys. And when we move it, it'll make the stars look like little fireballs in the night sky. So we're playing around with that just so we can actually get the full nebula in view for us. So that's what we're doing here. Jogging the telescope is a very common thing to do, especially if an object is really big, like the moon. Sometimes if we want to look at a different section of the moon when we're looking at it through this telescope, we have to jog the telescope in order to get to that section or something like that. So it's useful for all types of things. So that's why we're doing it. So it looks like that's pretty good. We're increasing the exposure again. So we have, again, that pink nebula right in the center. Towards the top, we have some of that blue nebula, and then we have that dark nebula cutting right in between. So we should get the new exposure. There we go. Lots and lots of colors through here. So the emission nebula is the pink one, the reflection nebula is the blue one, and the dark nebula, which basically just means that the light is dark and it's obscuring light from behind, is that dark stuff cutting across in front. So this was just really cool. I like seeing the color difference. They're like 2 lobes right next to each other, which is pretty cool. Not a lot of nebulas have this type of structure in it, but that's kind of neat to see. So, oh,
can you hear me now?
Yes, we can hear you.
Change my audio. Cool.
It sounds great.
Also, G sets. We are looking into the past anytime we look at any of the stuff around us. Stuff that's much closer to us, we're seeing much closer to what it looks like right now. Like the sun, we're only seeing about 8 minutes in the past. But if the sun were to explode, there would be no way of us knowing for 8 minutes. No one anywhere would have any idea that it had exploded for about 8 minutes.
This is true. On like a very like quantum level, putting the computer delay aside, if I were standing right in front of Wesley, you would be looking at me in the past at like fractions of a millisecond. But it's true for literally everything that we look at, because light only travels so fast, and there's always going to be a tiny bit of delay, whether it's something right in front of us or something that is billions of light years away from us, which is totally crazy to think about. But hey, I always say astronomy is the closest thing that we can get to time travel, at least in the past.
True.
So,
it's very true.
Yeah. Kind of cool to see.
Very easy to time travel forward, though. All you have to do is run really, really fast in a circle.
That's true. Yeah, that is
There's
true.
something called time dilation that you only really experience on the ISS because it's moving really fast. So when the ISS makes if you're up in the ISS for like a year, you'll experience 6 seconds less of time than everyone here back on Earth.
Which is cool to think about, because only a couple years ago, Scott Kelly was in the ISS with his brother Mark Kelly. So they're twins. And Mark Kelly was down on Earth. Scott Kelly was up in the ISS. So Scott Kelly was, 6 seconds younger just by being up in space for a year, which is kind of funny. So that's a cool thing. But we want to go back to Jupiter and Saturn to end us off, because we only have a couple minutes left. So let's go to Jupiter first, and then we'll end with Saturn again as kind of like a bookending type thing.
Real quick, G-sets. If you were able to magically right now, like teleport millions of light years away from the Earth, and then you had some sort of telescope that was like way more powerful than any we could design, then yes. But we don't have any way to like resolve the surface of planets outside of our solar system, much less outside of our galaxy, which is how far away you'd have to be to see the dinosaurs. And also, if you were like moving at the speed of light to get there, then the Earth would be in the future. It's like a whole thing. But if you could magically teleport really far away and construct this magically powerful telescope, then yes.
That's pretty cool. I don't know if we'll ever do that though.
Probably not.
Yeah.
Anyway, look at Jupiter.
We have Jupiter for you guys. So it's pretty low to the horizon still, meaning that we're fighting with lots of atmosphere. So it's kind of wobbling around a lot. And the colors may look a little more blended together, you could say. But hey, we're still getting some of that striping coming through, which is really nice. We have that nice stripe on the top. I call these, when we look through the telescope, I call these the bacon strips of Jupiter, because they look like bacon strips on the surface. So that's just my cheesy thing of the day or the night. But anyway, the striping is a really cool phenomenon on the surface of Jupiter. So the color difference is caused by slight differences in the composition. So some things might have more ammonia or more methane than something else. But also, it's the actual separation of the stripes or the bands is caused by the winds moving in different directions on the surface of the planet, which is really cool. So that's kind of a fun thing about Jupiter. Jupiter is the biggest planet in the solar system. It has 79 moons. Speaking of moons, if we kind of overexpose the planet, we can grab at least the 4 Galilean moons for you guys, which are the first 4 moons discovered besides our own by the very own Galileo Galilei back in early 1600s. So I know Wesley has a fun fact about that.
Yes.
Like to say.
The discovery of the Galilean moons around Jupiter was some of the first evidence used to prove that the Earth was not the center of our solar system, because the belief at the time was that since everything we could observe went around the Earth, that the Earth was the center of the universe. But we could see very clearly that these moons were orbiting around something that wasn't the Earth. Galileo found them and observed that, and so it was proof that that was not true. And so part of what proved the heliocentric model.
Sweet. Accumulating evidence. I was telling a guest that fact basically just yesterday. And they were like, that's really cool to think about, because he mentioned that when he was a kid in school, they would only teach that the only planets that existed in the universe was within our own solar system, because we hadn't found exoplanets yet.
Yeah.
Which, of course, nowadays we know that there's many, many planets orbiting other stars in our own galaxy, orbiting other stars in other galaxies, at least we think. So it's just kind of interesting that maybe we don't necessarily teach it right away. There might be speculation, but until we find the evidence for it, we can't really say otherwise, which is just cool how science evolves like that. So just a fun thing that I thought I would share. So the 4 Galilean moons in name before we head to Jupiter, or sorry, for Saturn for the last 3 minutes are Io, Callisto, Ganymede, and Europa. I don't know which order they are in tonight, so I can't necessarily say, but those are some of the coolest moons of the solar system. Literally, some of them are just ice balls, so kind of cool. But let's head to Saturn for the last couple minutes, and then we'll wrap up for the night. So let's go back there, and then we can hopefully see a little more detail on the rings, also the planet, and then maybe also some of the moons as well. So let's head to Saturn. Pretty close to Jupiter in the night sky, same-ish area. So if you wanted to view Jupiter and Saturn tonight, they're going to be some of the brightest objects out for us. They're going to be in the southeast, in that direction. So Jupiter will be like basically the brightest object out tonight. Then Saturn will be just a little bit up and to the right of that object, and they'll look like unblinking stars in the night sky. So here's Saturn. So it looks like we can see that separation between the planets and their rings a little bit better now that Saturn's a little bit higher in the night sky. So we have that nice coloration going on. Let's see. I'm just checking. I know we had a couple comments about Saturn earlier, so I'm going to make sure I look at that. Let's see.
Really gorgeous planet. Super picturesque, honestly.
Yes.
Furthest planet in our solar system that we've known of forever and ever and ever, because it's the furthest one that you can just see with your naked eye.
That's true. Yeah, it is the furthest one. So the first planet to be discovered was the planet Uranus, and then we've known about all the other ones up to Saturn. Now we think Saturn is named after the Roman god of agriculture and time. And we think they named it after the god of time because to us here on Earth and to the ancient people observing this planet, it was the slowest one to orbit around the sun because it was the farthest out that they could see. So it just took forever. And they were like, we're going to name it after the god of time just to remember that, I guess. So.
That's funny.
Yeah, I think it's funny too. So it's kind of interesting how we think that, but This is Saturn. So we're going to wrap it up for tonight because we're at about an hour for our interactive stargazing. So we're going to try to do this every month. So tune in for September and we'll do this again. There'll be a whole new set of objects that have risen for us and we'll take more requests just like last time. But I want to thank you all for joining us tonight, and I hope you had a good time. And let us know if you have any comments after the live stream. Oh, and also we have the Clark 125th live stream coming up on the 19th of August. So tune in for that. That's going to be a special live stream that only happens this year for the Clark Telescope's 125th anniversary. The Clark Telescope is one of the oldest telescopes on our Lowell Observatory campus. It was what our founder used to study Mars for most of his time up here. So look out for that on August 19th. But I think that is the last live stream I need to mention until the next interactive stargazing. But Wesley, if you have anything else to say, sweet.
Oh,
so
I'm done here.
Perfect.
Thanks for coming, folks. Hope you enjoyed it.
Cool. Hope everyone has a good night. See you next time.
Get home safe. Tip your waitresses.